lesson is 5.3. There's a refraction of the wave. Okay, let's see what's this topic talking about. Okay, let's see the first one I want to introduce is wavefront. I think the last lesson they also got talking about a wavefront. Okay, let's see this part. Can you see the diagram? Okay, when I draw the line AB and CD, okay, all the points along the line AB are in phase. Both also is a crest, so we say there's an in phase of the vibration and have the same displacement. Okay, line AB which join the point in the phase in a wave, we call it as a wavefront. So the line CD also we call it as a wavefront. Okay, first one you see the diagram. Okay, diagram they show about the direction of the wave propagate. Okay, always go to right hand side. Then the wave front is always perpendicular to the direction of the propagate. So when they draw the line, there's a crest, two dotted line, that one is a wave front. Okay, now we straightforward go and see the frame. The fringes formed by the screen. Okay, what color? We can say bright color. The bright color part is stand for the crest. Then the dark color fringes part is stand for the truth. So that means for the crest or the light focusing. When the light focusing, we find it as a bright color. Okay, for the truth, we find it all the light ray they will divert. They will open wider. So we find center become darker. So this one is a result formed by the screen. Okay, now we're going to see when the light ray they move through the water in the river tank, then you can see the alternate bright and also the dark fringes on the screen. Okay, so this one is a result. Okay, let me go and see the second page. Okay, let's see the second page. This one is a wavefront for the plane wave and also circular wave. Okay, now you can see about the blue color line. The blue color line is stand for the wavefront. Then the pink color line is stand for the wave travel. So from here, can you find it? Both also must be 90 degrees. So this one is a plane wavefront. This one is a circular. So the direction of the wave pattern, they also go to every direction for circular part because they want to go every outside. Every part of the outside, they want to lose the energy. So from here, when you draw the circle for the wavefront, then the direction of the wave propagate must be 90 degrees with the wavefront. Okay, now you're going to see the explanation. Direction of the propagation of the wave is perpendicular to the wavefront. So they just want to tell you direction of the wave perpendicular to the wavefront. Number 2, wavelength. Wavelength, remember wavelength? There's a lambda. The same as the distance between two consecutive wavefront. So this one, two consecutive is very important. Two consecutive means the first one crest, then go to second crest, then we call consecutive. If the first one crest, you go to third crest, that one not consecutive. So wavelength must count from the first and the nearest second one. That one we call two consecutive. So this one we call wavelength. Now we're going to see the light ray how to travel through the water wave. Okay, first one, can you see there's a straight line only, go down. Okay, another line, when they're just touching about the truth, they are bending away. So this part we call there's a dark fringes because the light cannot focus. Okay, now we're going to see the crest part. The crest part, when the light just go through, you find it all focusing to one point. So this point become bright fringe. So now they will continuous lah. After the bright must be the dark, then followed by the bright. So from here, this one is a formation of the bright and dark fringe by the light ray. So this one also is a result. You can see through the screen. Okay, this one is a plane dipper. Then they produce is a dark and also bright straight line. This one is a circular. So you can see about the bright one is a crest. Then after that, the dark one is a truth. So they will continuous. Okay, now we're going to see the explanation. The bright fringes, they correspond to the crest. and the dark fringes, they correspond to the truth. So this one just explanation about the crest and also the truth. Okay, this one is go through to the reflection of the wave. This one just follow your notes. Okay, first one we're going to see what means of refraction. Reflection of the wave, they occur when the wave they strike to an obstacle. That means something blocking the wave. After that, they will come back. So this one situation we call refraction of the wave. Okay, the wave is undergo a change of direction. When it just come back, the direction changes already. So this one we say direction propagation will be changes after reflected. Okay, now we're going to see the law. Okay, refraction of the wave must obey law of refraction. Okay, we got two of the law of refraction. Let's see the first one. First one is the angle of incident is equal to the angle refraction. So you can see the diagram here. This one is called angle incident. So we label with delta I. Okay, another part is an angle reflected. So we label by delta R. Okay, both also must be equal if we follow the law of refraction. So this one is the first law. Okay, second law, incident wave, refracted wave, and the normal line. Okay, line, L-I-N-E. Okay, must be line and in the same plane. So this one is a barrier, is it? So we got three lines here, incident ray, normal, and also refracted ray. These three lines must lie at the same barrier. So this one is a second law. So you must obey these two laws, then we say you are obey the law of refraction. Okay, now we see this diagram. Okay, we need to know how to draw. First time we start with the incident. Okay, incident must start, go in the barrier. That means the ray must be hit the barrier. Okay, when they hit to this point, you need to draw normal line. Okay, what we call normal line? Normal line is a one straight line. They're just perpendicular to the barrier. Perpendicular to the barrier means 90 degrees. Okay, after that, this we call incident angle. So you need to start how many angle, then you need to measure by using the protractor, then you start. So example, you set 20 degree. Okay, now after you set 20 degree, after you draw the incident ray, after you draw the normal, okay, now you need to draw is a wave pattern. The incident wave pattern. Incident wave pattern must be 90 degrees with the incident ray. So I can say blue color line, 90 degree with the red color line. Okay, so this part we call incident part. Now we need to see is a reflected part. Okay, if follow the law, both angle must be the same, is it? Okay, if you just now set 20, here must be 20. So you use a protractor to measure again, then you draw refracted ray. After you draw the refracted ray, then you continue to draw the wave pattern. The wave pattern must be 90 degrees with the refracted ray. Okay, one more thing you must know. Before that, the lambda is how many? After that, the lambda also must be the same. If you set starting 1 cm, so that means refracted ray later the wave also must be how many cm? 0.2 cm. Okay, if you set 1 cm, this one must be 1 cm. Okay, so this one is how to draw the refraction of the wave. Okay, now we're going to see what happened. After refraction, what happened? Okay, we separate by two things. One should be changed, another one is unchanged. Okay, let me see which one is unchanged. First one, wavelength. That means the wavelength before and after should be the same. Okay, number two is a frequency. Frequency must be same because they're using both is the same motor from the river tank. Unless you change another river tank, then the frequency will be changed. So from here, both frequency must be the equal. Okay, third one is the speed. The speed of the wave must be the same. Okay, now we see what changes. Changes just got one. There's a direction. Because now direction is go in, is it? Another direction must be far away. So this one is changes. Okay, for here, we need to know how to draw. Okay, how to draw the refraction water wave. Okay, let's see the diagram here. Okay, they got incident wave. This one is a plane reflector. So that means you must start drawing is a A. Step A. Okay, step A, they start to draw incident ray. Okay, touch to the B. Okay, after that, we stop. So this one is an incident ray. Okay, then you need to draw is a line. Wave incident. Make sure there's a 90 degree with the pink color line. And also the lambda is equal. Wavelength is the same. Okay, now another line you need to draw to the another part. Then you adjust the I and R. The two of the angle must be the same. Then after that you draw the refracted ray. After draw the refracted ray, the last one, step 4, you're going to draw the line. The line must be perpendicular to the red color arrow. After that, and also must be same lambda. So this one is a step how to draw. Okay, now I will show about the step to be draw the diagram of refraction of the water wave. Let's see here. Okay, now we're going to see the incident ray. Okay, this one is an incident ray. Okay, now I need to draw the first one is a normal line. Normal line must be 90 degree with the plane. Okay, now we start with draw the refracted ray. The refracted ray, the angle must be same like the incident ray. So make sure you're using the protractor to measure. Okay, after you draw the incident ray, now I need to draw the wave pattern. So the refracted wave pattern must be 90 degrees with the refracted ray. So when you draw, you must using your ruler to measure. Make sure there's a 90 degrees. Okay, now we need to draw the second one. Okay, when you draw the second one, make sure the wavelength is same like the original. If the original is 0.2 cm, so that means your refracted wavelength also must be 0.2 cm. Then you continue to draw. Okay, so this one is how we go to draw the refracted ray from the plane diagram. Okay, make sure you know the step. Okay, we got some of the example here. Okay, this one is from your exercise. You can see. Okay, first step is direction of the wave to go in. Then after that, we got the line here. Okay, the line must be perpendicular with the direction. That one is a wave pattern incident. Okay, now we need to draw is an arrow to come out. The arrow to come out is a wave to come out. So make sure you draw the direction first. After that, we draw the wave pattern. Okay, let's see here. First one, we draw the arrow. The arrow must be go out. Okay, go outside. Okay, now we draw the wave pattern. The wave pattern must be 90 degrees with the direction of the wave. So I know when you draw, they must overlap to each other line for the incident wave. So I just want you to draw a little bit side. Then after that, you can show that one is a refracted wave. Okay, let's see here. So this one we call refraction wave. Then using the dotted line and also a little bit beside about the incident wave. So you can see clear that one is a refraction. Okay, another one is from your notes. They also got answer already. So this one is a bigger. The wavelength is a bigger one. So you find it. The refraction also is a straight line. Okay, now we're going to see the third part. Third part, we got sliding a little bit. Sliding. First one, you're going to see the arrow. The arrow is straight forward going, is it? Then hit the barrier. Okay, when they hit the barrier, then we need to draw the wave pattern. The wave pattern must be 90 degrees with the incident ray. Okay, now first step you need to draw is a normal line. Normal line must be 90 degrees with the barrier. Okay, then after that, after you draw the normal line, we make sure this angle is how many? This angle we call it incident angle. Okay, now if you find the incident angle is 25 or 45, then another one, the refracted ray, you must draw with 45 angle. So we start to draw. Okay, so I find it incident angle, refracted angle become the same. Okay, last part, we need to draw the wave pattern. The wave pattern must be 90 degree with this one red line. So we see first one. So you draw perpendicular with the red color, the refraction of the wave. Okay, then you just continue and make sure the lambda same as original. Okay, so second, third, and fourth. So this one is an example how we go to draw the refraction of the wave. Okay, for this one topic, we got two of the experiment. There's a one is a relationship between the data I and data R. So from here, the angle of refraction increases, the angle of the incident also decreases because both is the same. So from this one experiment, what we want to do, we need to find the relationship between the angle incident and angle refraction. So from here, manipulate variable is the angle incident because you're using the protractor to measure. Respondential angle refraction. Okay, fixed. Depth must be fixed. The water depth. After that, you can say about the frequency. You can say frequency must be the fixed. Okay, now we see the apparatus. We're using ribbon tag, LED, bottle, wooden bar, power supply, widescreen, protractor. You must mention protractor, plane refractor, and mechanical stroboscope. Okay, mechanical stroboscope is very important. If you never mention, that means we cannot do the experiment. So we count the experiment is not function. Okay, let's see the arrangement of the apparatus. Okay, we can find that this one is a drawing. So make sure you need to draw the stroboscope. Okay, important is a stroboscope because stroboscope later they can freeze the wave pattern. After that, we can do the measurement. Okay, let's see the procedure. Apparatus is set up. Then we're using the protractor. The angle of the incident you need to set by yourself because there's a manipulate variable. Then you must say power switch on. So all the things we highlight already. Then switch on, they produce a plane wave, propagate towards to the refractor. Now the incident wave and refractor wave are freeze. You must say the number 3. You must freeze by using the stroboscope. After that, you sketch the pattern on the screen. Then you're using the protractor to measure the refractor angle is how many. Then you need to record it. Last one, important, there's a repeated. Repeated minimum of 4 set. Then you mention the 4 set is what. So this one is a tabulate the data. Okay, after that is analyzing the graph, R against the I. So you need to plot the graph. Okay, so this one is about the report. Okay, then we're going to see the application. Okay, this one is the application for using the refraction of the wave in our daily life. Okay, first one, the ultrasonic scanning. In the medic that involves the sending of the ultrasound. That means the ultrasound means the sound already over the human being can be listened into the patient body. After that, they want to detecting the echo which come back. So that means normally this part you want to scan anything, you want to detect is the echo. So that means the distance already is a two-way. So let's see number 2. This can be used, for example, to see the position of the unborn baby inside the mother wombs. So from here, the whole process is completely painless. Okay, don't have any pain. They just apply the gel on the stomach. After that, they also must be safer compared to the X-ray. Okay, so this one is why we're using the ultrasound to scan the internal organ. Okay, the another application that's used for detect the depth of the sea. So from here, they're using the radio wave from the communication satellite are refracted by the parabolic dish and focused onto the antenna, the feed horn. So this one also using for the aeroplane. They send the signal through the parabolic dish. After that will be refracted back. So after that refracted back, we need to count what is the distance between the satellite and also the plane. Okay, so for this part, the ship must be send the transmitter. Send the signal wave, radio wave from the transmitter. Okay, when the transmitter wave, there's a radio wave that hit to some of the object. Okay, after that, they'll refracted back. After that, you got receiver. Then you can do the calculation about the distance of the seabed. Okay, then you see the pattern of the refracted sound wave. They're also using for detect the different rock and able the location. Depth and also structure of the seabed, which can contain the success of the natural gas to be identified. So they also want to find the natural gas by using the refraction of the sound wave. Okay, let's see another application of the refraction of the wave. Okay, in the modern fishing trawler, okay, the echo, that means the sounding produce sonar. Okay, that means the sound navigation and also the wrenching, the echo sound to come back. They used to detect the shore of the fish. So the equipment can be detect the refraction pulse from a shore and work out its position and also the depth. So from here we can find it, where's the location we got fish. After that we just focus there. Okay, they're using the refraction of the sound wave. Okay, then we go and see the first example question. Okay, ultrasonic wave frequency. Okay, they already provide frequency 25 kilohertz. Transmitted from the ship to the seabed to determine the depth of the sea. Okay, this wave travel speed 1500 in the water. So the time between sending the ultrasound wave and the receiving the refracted wave is 120 millisecond. So from here we can see velocity is a two-way. You send and go back. So another one is a time taken. Time taken, sure you need to set. After that you want to refractor back, then we know the time taken is how long. So speed and also wavelength totally process is a two-way. Okay, but now the question they want to find is a depth. Depth we never count about two-way, is it? We count one way only. So now your formula should be velocity. Before that the velocity equal to the V equal displacement over the time. Is it? Displacement over the time. So from here, we need to find is a displacement. Okay, but now the displacement is a two displacement. Because velocity, they count two-way. Time taken also two-way. So understood your distance must be two-way. But now the question they never ask about two-way. They ask about one only. That's the depth of the sea. So we're using the formula, this one. V equal 2D over T. Okay, now 2 distance equal to the 1500 multiply with the millisecond. 120 millisecond. So finally the 2 must be go another side, divide. Then I get the answer is 90 meter. Okay, then we try the B. B is the ultrasonic sound length. So wavelength, sorry, is a wavelength. So how to find the wavelength? We just got one of the formula. There's a V equal F lambda. Now the question provided is a frequency. Okay, provide frequency. Then the speed we also got 100 and 1500. So we just apply V equal F lambda. Okay, then the lambda is how many? 150. Okay, divide by 25 times 10 power of 3. Okay, because of the frequency. Frequency is a kilo frequency. Then I get it the lambda 0.06 meter. Okay, example 2. Okay, example 2, you need to draw the wavefront and the direction of the refracted wave. Okay, so from here we start with the normal line. Okay, then you need to draw another refracted ray. The angle almost the same. Okay, this one incident ray how many? 90 minus 70, that's a 20. So when you draw the refracted ray, the angle between the normal also must be 20. Okay, so we start here. So this one is a plain one. Okay, we start with draw with the incident, refracted. Incident got already. We draw the refracted. Okay, after we draw, then we need to draw the wave pattern, is it? Wave pattern must be 90 degrees with the refracted ray. So I draw the first one. Okay, 90 degrees. The red color, 90 degrees with the blue color, dark blue. Then I continue to the second one. Make sure the wavelength is the same like original. Okay, so this one is the second one. Then after that, this one is the third one. So this one answer for the example 2. Make sure you know how to draw it. Okay, then we're going to see is example 3. Example 3, they show about the ultrasonic wave. By a ship, they want to determine the depth of the sea. Depth of the sea. When they say depth of the sea, understood, you need to divide by 2. So the interval time between the transmission receiver to the echo of the ultrasonic sound is 0.06 seconds. Okay, now the speed of the ultrasonic provided 1500, determine the depth. So we're still using the same formula, V equal 2D over T. Okay, so now we're going to see this part. Okay, so we get speed is 8. Then after that, the time taken 0.06. Then we divide by 2. So I get it the depth. Okay, they want to find the depth of the sea. Is it? There's a 45 meter. Okay, so from here. Okay, our lesson just until here. Hope you understand about this one. And also you need to practice how to draw the refraction of the light.